All right, welcome to LouTube and this video for the grade 10 math applied class and a review of their culminating activity. So this is for the grade 10 applied students, and I'm going to go over their culminating activity and provide some examples. I plan to do this in two parts, so this will be part one. And I'm going to go through some sample questions that match your review so you can follow along with your review or a copy of the actual culminating activity, whatever is your choice. Now, first of all, there is a series of multiple choice questions. I think 32 of them. I'm not going to cover them. I'm not going to discuss them. That you'll have to work on your own. But if you listen carefully as we go through this, you should be able to hear and find some of the answers with respect to your culminating activity. Okay, so let's move on and start with question one in the full solution component. And this is using the distributive property and collecting like terms. Remember, like terms are terms that have identical letter parts. So that's like the X's and Y's. And the number parts can vary, and you can add and subtract only those that are like terms. We can multiply or divide if they're not like terms, but only the like terms can be added and subtracted. And so I'm going to just go over this example, which uses a bit of the distributive property, and then move on, okay? So in this case, it's 2 times 3x minus 7 plus 4 times x plus 2. And what does that equal? So what we do is we multiply. I got to turn my pen on here, sorry. It's not liking me. Get the pen back on. Okay, I got it in black. 2 times 3x would be 6x. 2 times 3 is 6, and then there's just an x. And then 2 times minus 7 would be minus 14. And then we can do the same for this one. 4 times x would be plus 4x. It's positive because that's positive there. And then 4 times the 2 would be plus 8. Now we can collect the like terms. What's like? Well, 6x and 4x are like. They can be added, and so that gives me 10x, okay? And then the 14 minus 14 plus 8 can be combined or so added together. So minus 14 plus 8 would be minus 6, and we're now done. We cannot simplify further because we do not have like terms. 10x and minus 6 are not like terms because they have different letter parts, okay? That finishes the first question. Let's move on to the next question, which is expand and simplify. And there's a series of these. I thought I picked a couple I thought would be good. And so in this particular question, we have a x plus 6, and it's squared, which really means x plus 6 times x plus 6. And I thought I'd do one of these because I know that students sometimes forget these little steps that go along. Now we treat it like the other questions in this, and we use our FOIL, if you remember FOIL, or some use the bird, whatever method is you like. So the first two, that's the f, x times x equals x squared. And then the x, the outside two, that's where the O stands for. X times 6x. 6 gives me 6x, so plus 6x because there's a positive there. And then I move to the second term in the first bracket, and that is 6 times x, which will give me another plus 6x. And then finally 6 times 6, which will be positive as well, 36. Now I look for any like terms, and I do have these two middle terms are usually the like terms. First two, outside two, inside two, last two is where the FOIL comes from. That's these steps in here. And I end up with x squared. 6x plus 6x is 12x plus 36. And that is my final answer. Now, I'm going to do the same thing here with this one, but now there's some terms on the end, and we'll worry about them afterwards. But we will first deal with our multiplication. It's just like BEDMAS says, multiplication comes before addition and subtraction, and these are adding and subtracting, so I have to deal with these first. So I do the same thing as I did in the question above. That becomes x squared, and then I write x times the minus 7 is minus 7x. And then I go 4 times the x is plus 4x. Okay, and then 4 times the minus 7, which will be minus 28. And then what I do is I simply write out what's left because they're not multiplying by that. They're being added and subtracted. And now what I've done is I've gotten rid of all my multiplication in this. So I can now worry about doing my like terms. And so I look through here and I go, do I have any like terms? And I do, x squared and an x squared. So that's going to be 2. 1x squared plus 1x squared is going to be 2x squared. I'm adding them, right? Then I have 7 minus 7x plus 4x. And then I look for any other x's. I have a 2x. So if you think about it, I am at minus 7. I move ahead 4. That's going to bring me to minus 3. And then I'm going to move ahead another 2. That's going to be minus 1x. Now, we don't usually write the 1 when it's just 1, so we just write minus x. But if you put it in, and I'll write mine in here, a little faded dotted line, it's not wrong to write the 1 in front of the x, okay? And then last but not least are just any terms that are numbers alone. And I do have 2 numbers alone. I have minus 28, minus 16. And this is always tricky for students. They always get caught up here. But if I'm subtracting, starting at minus 28, and I'm going backwards another 16, I'm actually going to be like minus 42, I believe, is what that works out to. Oh, sorry, I apologize, minus 44. Minus 44. Okay, caught my mistake there right away. So off we go. And that is the final answer now for this. Whether you put the 1 in there or not is irrelevant. Okay, let's go to number 3 on our question. Here we are doing something called factoring. Now, if you remember, factoring is making a multiplication question. So what I'm doing is I'm looking for common factors. And I'll usually start with my numbers and I'll say, look at my factors list. Oh, remember that sheet that we did? I even sold some of those sheets to people that we ended up donating that money. But here what we did is we have these factors lists, and we can look for what number is a factor of each of these. And it turns out that 6 times 3, 6 times 6, and 6 times 5 are factors of each of these, which means that 6 is a factor here, okay? So I'm going to take a 6 out. Oh, before I write my bracket, I better erase that bracket. It's going to get in my, oh, come on, eraser. Come on. Help me here. No, it does not want to erase for me, folks. I don't know why that eraser will not work. That is just so strange. I get stuck here. Okay. Well, we'll have to squeeze it in. Then I look at the x's, and how many x's do I have, and what can I factor out in x's? And I have a power to the 5, a power to the 4, and a power 2. So the highest x value I can take out is an x squared. So I can remove x squared there. So I'm going to put an x squared right there. And that's where I wish I could erase that. But for some reason, my eraser just does not want to work for me. I have no idea why it does that. And let me write my answer down below then, and that way at least you can see what I'm writing, okay? So I'm going to, oh, now my pen doesn't want to work. Okay, 6x squared, and then I'm going to put my bracket, okay? And that means that what did I do? I have to divide 18 by 6. That'll leave me with a 3. And I'm going to take 2 x's away from the x to the 5. That'll be x to the power 3, okay? Essentially, I'm dividing the x to the 5th by x squared. And then I'm going to take my x to the power 4 and divide it also. Oh, sorry. First, the 6, 36 divided by 6 is going to leave me with 6. The minus will stay there, x, and I'll be left with an x squared. And then finally, the x 30 divided by 6 is plus 5, and there is no x squared. I took it already out. It's out here. That x squared is out here, and I close it off. And that is it factored out, okay? They're tough. They're not easy, but they're not difficult if you just stick to the steps and work your way through, okay? Well, now it's deciding to, oh, crazy. It's deciding to follow me down the page. I'm just going to close my screen and reopen it again. So just bear with me for a second. I will not save it so that it doesn't show up there. No, I don't want to save anything on there. And I'll open my window up again and get that file back open and get to that position. So just bear with me for a second. And here we go. Maybe not. Yep, there we go. Computer runs a little slower when it's recording. So there we go. Now we can go down to the next questions. Number 4. We're on number 4. And this is factoring. So remember, when we have a trinomial and we're factoring a trinomial, we're always going to end up with 2 sets of binomials. Remember that? So the first thing we do is we write our brackets in, and then we write our x's in, right? Then I said to you, remember, if this is negative, that tells me one is positive and one is negative. The only way this number is going to be negative is if one of these numbers is positive and one is negative, because those two numbers that we put in here will multiply to give me 15. So I know that they are positive and negative. And because negative is in the middle, I'm going to start with the negative here and the positive here. If this answer is positive, remember, either both of these are positive or both are negative, depending on what the value of our B term, our middle term is, okay? Then I look for factors of 15, and I can list them all. 1 times 15 and 3 times 5. Those are all the factors. Which one has a difference of 2? Well, 1 and 15 have a difference of 14. That's not going to work for me. Cross that off. 3 times 5 has a difference of 2. So therefore, that's the one. And the bigger one goes with the sign that's on the B term. So that goes 5 and 3. And if you were to go back through and multiply this back out, you will come back to this answer. And that's why this is factoring. I've turned this into a multiplication question. It is x minus 5 times x plus 3. All right, let's continue on down to the next one. Okay, now we're going to start solving equations. So now we're going to be looking for the value of, in this case, x. Okay, over here it's r, but in this one here it's x. And we're going to use the skills that we've been using above and are collecting like terms and various other things to do this. So the first thing we're going to do is use our distributive property to get rid of the brackets. We have to get rid of those brackets here. So there is a series of multiplications that we need to do. 2 times 4x will give us 8x. 2 times minus 4 gives us minus 8. And that equals 2 times x, which is 2x, and 2 times 4, which is plus 8. And then, of course, the plus 2 goes on the end. Now, we're getting closer to solving it because we've removed our brackets. And now what we have to do is start looking at what we have to move where. And remember, terms with letters go to the left side. Letters and left. Numbers go to the right side, okay? LL, letters left, numbers right. So in this case, this has a letter in it. It's okay over here, but the negative 8 is not. I need to get rid of this. Well, how do I get rid of negative 8? I add 8. Minus 8 plus 8, that's going to be 0. It's going to disappear for me. But then I need to add 8 on this side to keep things balanced, because the golden rule of solving equations is whatever you do to one side, you must do the same to the other side, okay? Now, if I look over on this side, the 8 and 2 are okay there because they're numbers and they're on the right side, but the 2x is not. So I'm going to subtract 2x here, and when I subtract this 2x, that's going to become 0, and then I'm going to subtract 2x here too, and that leaves me with 6x equals, and what is my answer? Well, I have to add everything up, and the answer is 8 plus 2 plus another 8, and that works out to 18. Now, I'm not quite done. I'm almost there. I need to solve for what x is. And this 6 is multiplying by the x. And the opposite operation of multiplying is dividing. So I divide by 6. I divide by 6. I do the same thing on both sides of the equation. 6 divided by 6 leaves me with 1x, and 18 divided by 6 equals 3, and there's my wonderful final answer to the question. X equals 3. If you were to actually put x back in here and solve each side, you would get both sides being equal. Okay, now I'll do one with fractions because I know that those are always challenging. Remember, the key thing to remembering how to solve fractions is as soon as you see a number here on the bottom, a denominator, multiply by that denominator. So if I multiply this side by the denominator, these cancel off, and I'm just simply left with 4r plus 7 equals. But if I'm going to multiply this side by 5, then I have to multiply this side by 5, and that will equal 15. And as soon as I do that, I end up with this relatively easy equation, which is 4r plus 7 equals 15. And it's much easier to solve. What's on the wrong side? Just the 7. So I subtract 7 here, subtract 7 here. I end up with 4r equals 8. Okay, 15 minus 7 is 8. 7 minus 7 is 0. Those two disappear. Now I want to get rid to r. It's multiplying, so I'm going to divide by 4, and I'm going to get r equals 2. And my final answer is r equals 2, and I'm all done. Okay, let's move on down to the next one. This time we're solving something with a square in it, okay? And I chose to do a little tougher one. I didn't pick the easiest one here. And I did that on purpose because I know that students will struggle. So what you want to do is isolate the squared part, okay? In that case, this is the squared part. Then we can use that beautiful feature called square root. We can square root both sides, okay? Now, what we do is we say that we're going to move the 11 to the other side. That's how we're going to isolate that squared part. So we move 11 here, and we end up with 36. And that leaves us with x minus 3 squared equals 36. Well, what's the next step? Square root both sides. When we square root this, that will simply leave us with x minus 3 equals the square root of 36, which is plus or minus 6. And what this means is we have two possible answers. We have x minus 3 equals positive 6, or x minus 3 equals negative 6. And now we can solve each of these. What does x have to be if I subtract 3 to get 6? Well, most kids will see that if I add 3 to both sides, I'll end up with x equals 9. And that's one answer. And the other answer is x, whoops, a daisy. Something didn't like me there. Get back down here. Sorry, I apologize, but sometimes the computer has a mind of its own. Here we go. Apologize. I probably put my palm on the wrong part of the computer here. This side, whoops. I'm going to go. Oh, it does not like me right now. I need to get that cursor moved into a different place here. And I need to just zoom back down a bit here. Okay, there we go. Let's see how this works now. So now I'm going to add, well, it still doesn't want to do this for me. Apologize. It's not letting me use my pen. It does not want to do this. I don't know what happened here. I'm just going to try to get my Huh. I'm hitting escape. I'm doing everything. Trying different things. It just does not want to let my pen work. So I'm going to have to open and close again. But I'm going to tell you that the answer here is x equals, I'm going to try and type it in, x would equal, add 3 to both sides, so it'll be x equals minus 3. So the other answer would be x equals minus 3. I'd write that in here, but it will not let my pen write right now. I'm not sure what is going on with this. So I'm going to close this and open it up again. Very finicky, the program, but I'm doing my best with it. So bear with me. I'm not going to save this, and I'll come back to it. Okay. Let's try that again. See if this time it's going to let me open it up and not be all messed up. Here we go. Open. Yeah, why is it so big now? I'm not sure what's going on with this thing. There we go. It's in a different format of some sort. I don't know what I did to... Ah, there we go. There we go. I think I figured out what I bumped. Okay. Let's get back to where we were. And the other half of that answer, I think, just to finish it off, it was x minus 3 equals minus 6, and it ends up being x equals, so we add 3, and it becomes minus 3. And so the other answer, I believe, was x equals 9, and we end up with these two answers for this question. And that means that you can put either 9 in here or you can put minus 3 in here, and it works out. And what ends up happening is if I put 9 in, I get 6 in here that gets squared. And if I put in minus 3, it's minus 6, and minus 6 squared is also 36. And that's why it happens to work, okay? So there's a couple of questions like that for you to work on. The next one is to solve a trinomial using factoring, okay? So what we're going to do here is, if you get a trinomial like this, you need to first isolate the trinomial all to one side. And generally speaking, we move it to the left side, okay? But it wouldn't matter if you did it to the other side. I don't really care. So what I'm going to do is I'm going to have this to be plus 35 here, and that's going to add 35 over here. And I get x squared minus 12x plus 35 equals 0. And now I have a trinomial that I can factor. And remember, factoring is like this, so I'm going to go like this. And in this particular case, put my x's in, right? Factors of 35 that add to 12. Well, that's 7 and 5, and my signs are both negative because this is negative here, and that equals 0. And what this does is allows us to right away draw answers. This is a number multiplied by a number. The only way we'll get 0 is if this number is 0 or this number is 0. Well, what does, if I look at it, if I look at this part here, what does x have to be for this to be 0? Well, x has to equal 7. So that's one of my answers, right? If I put 7 in there, it'll be 7 minus 7, that'll be 0. And it doesn't matter what this is, because when I multiply by 0, the answer is 0. And the other answer that I'll get is when this part is becomes 0, okay? So if I put 5 in here, because 5 take away 5 would be 0, okay? So 5 is another possible answer. So there are my two answers, and we often write them like this: x equals 7, 5. You could write that as x equals 7 or x equals 5. It's your call. It doesn't matter. I'm not going to worry about it. Okay? There's a couple questions like that you have to do as well. Okay? And then we're going to move on and do some graphing, okay? Now, I'm not going to spend a lot of time on graphing these special ones, but there is one on there, number 8. And so when you graph a special one, remember, all you have to do is, this is my x-axis, remember, Cartesian coordinate, that's my y, so horizontal x, vertical y. And then if I want to graph it, it says y equals 5, I go, well, where's y equals 5? I count on the y-axis, 1, 2, 3, 4, 5, and I draw a horizontal line because all along that line y equals 5. So that would be y equals 5 right there, okay? Now, if I give you one that says x equals, say, minus 2, then I go on the x-axis and I find minus 2, and that'd be 1, 2, that'd be right here, and this will be a vertical line. So that'll be like x equals minus 2, okay? And that is just a couple of examples of those special equations, okay? Now, most of what we did in class was graph equations like this using the slope-intercept form. And there's a couple of them there for you to do. I'm going to do one. So step 1, you'll have heard me do this a million times. Get yourself a mark. It's so easy. Go like this. Put your arrows on and label correctly X and Y. You're going to earn a mark just for doing that. So it's so easy, okay? Now, there are 2 numbers here, one in front of the X and one after the X. This is my slope. So my slope equals a symbol that we often use is M, and it equals minus 3, which actually means that it's minus 3 over 1. And the reason we write it that way is because the top number represents the rise and the bottom number represents the run, okay? Then we have another number here. This is our Y-intercept, okay? Now, the number we use for, or letter we use for it equals B, and in this case, it equals 2. All that means is this is where it will cross the y-axis. Intercepting means to cross it, okay? So we go to y equals 2, 1, 2, and that gives me my starting point. This is my rise, this is my run. And remember, my sign tells me which way I turn. Positive, I turn to the right. Negative, I turn to the left. So in this case, I'm going to go 1, 2, 3, and I'm going to make a left turn and go 1 unit. There's a point. Then I'm going to go 1, 2, 3, and then I'm going to make a left turn, and I can plot another point. Now, I have already 3 points. I can go down 3, and I can see the pattern clearly that I'm going to go 1, 2, 3 more, and down this way. I'm turning right as I go down because I have to keep that line going up to the left. And then when I'm all done, I can draw my line. Now, in this particular case, I will use my computer to do this, but you guys are most likely going to grab a ruler and draw this with a ruler. If you don't draw it with a ruler, you will lose marks, okay? You are not allowed to draw that with just free hand. You can't just go like this and sketch the line. No, I'm not going to let that happen, okay? So don't do that. Once you've drawn the line, there's one last thing that I always harp on, and that is to label the line. Y equals minus 3x plus 2, and you are done. That's all there is to it. Some of the equations come with the slopes that are like 1 over 4. There's my rise, there's my run, right? That's my rise, that's my run. So if that was the case on this one, I'd be rising run, and because it's positive, I'd be rising 1 and running 4, and I'd go this way, and the line would go in this direction. Okay, that was not the case for our particular assignment, okay, or question that I just did. Then the next step is to solve linear systems, okay? And we're getting halfway through this, and then I'll take a break, okay? So in this particular one, we're going to solve linear systems. So what we have to do is we have to graph the 2 lines. Once again, pick up some marks here. X, y. And when we're graphing a linear system, we're always looking for the point of intersection. So we're looking for a POI, that point where the two lines cross, okay? I'm going to graph these quick and dirty because I did a long one up above. So -3 is my y-intercept, 1, 2, 3, right here. And then I'm going to say my rise is 1 and my run is 3. 1, 2, 3, right? Okay, come on, girl. Give me a dot. There we go. 1, 1, 2, 3. And there's my line, okay? Now I can graph this line. Now, one of the things I'll do with these is I will label it, and I'll show you how I go about labeling this. So I'm going to draw this like this. Make sure I stay on my grid dots, okay? And I've got it in there. And I'll label this one A. And what I do is I put an A up here, and then I put an A down here. And then I'm going to label this one B when I get to it. And this is just a way to help keep it cleaner on my page, okay? So in this particular one, my slope is -1 over 1. So it doesn't put it in there, but we know that a minus in front means -1. No number in front just means 1. And so now what I'm going to do is I'm going to go to my y-intercept, which is 1, and I'm going to rise 1 and go to the left 1. Rise 1, go to the left 1. Rise 1, go to the left 1. Rise 1, go to the left 1. And that makes a -1 slope, okay? So I'm going to draw this line, and we'll see where these two lines come together or intersect, okay? Where do they cross each other? Well, if I extend this one through, look at that. It looks to me like they're crossing right there. This would be B, and I'd see that right at this point they're crossing. And so I need to give you the coordinates to that point. So remember, that's an ordered pair. The ordered pair would be the X first and then the Y. So I count over the X, 1, 2, 3, and down 2 would be -2. So I've got my point of intersection. That's what I'm looking for, my POI. So all I have to do is write a concluding statement. So I say, therefore, the POI is, and I write 3 minus 2, and I'm done the question. All the work's done. So marks are going to be awarded for writing the concluding statement, doing the graph, labeling the graph, making sure your X and Y's, arrows, all those things are there, okay? And it works pretty good. There, sorry, that funky thing, just to let you see there for a second before I move on, okay? So now let's move on to number 11, which is a question on elimination. So essentially, what we're going to do here is the same thing as up here, but we're going to do it without graphing. We're going to find the X and Y coordinates, and we're not going to graph. And in this particular case, we're going to use a method they call elimination. Well, how does it work? Well, the first thing you need to do, and again, easy peasy marks right here, is give your equations names. You guys know, you're probably laughing right now because it's class. I often give my names. Names of ex-girlfriends and stuff. But for today, I'm going to keep it simple. We're going to just go A and B, okay? And I am now going to recognize I have what I'm looking for is opposing values. So in this particular case, 1x and 2x are not opposing values, but 1y and -1 are. And if I add these two together, they'll be 0. And that is the ticket here. So what I'm going to say is I'm going to say A plus B. Now, if this was plus Y and that was plus Y, I'd be subtracting. But because they're opposites, I'm going to add. And when I add, they're going to become 0. So I add every one across. X plus 2x is 3x. Y plus -y, that's 0. It's gone. I don't need to write anything. I could write 0, but I don't need to. I'm not going to do it. It makes it messy. And then I say 7 plus 2 is 9. And I'm left with this nice equation, 3x equals 9. I divide by 3 on each side, and I end up with x equals 3. I now have half of my answer for my point of intersection, because remember, a POI includes a POI, I messed that up there, includes an x value and a y value in my coordinate. And so I'm going to come back to doing this. So what I'm going to do now is I'm going to say I am going to sub x equals 3 into, and I can pick either A or B. In this case, because B's got a minus sign and the numbers are a little off, I'm just going to choose A. It's nice and easy, okay? So I go like that. That means 3 is going to take the place of x in here, and then I can solve for y. So what I do is I write 3 instead of x plus y equals 7. And you'll see that that is the same equation as A, but now I've put the 3 in for the x. And now I can solve this. Well, subtract 3, y equals 4. Now I have my x value and my y value, and I write, therefore, the point of intersection, the POI, is 3, 4. And it's very much the same style of answer as I had here, where I graph them, but now I don't have to go through the headache of graphing the equations. I can simply do it by solving by elimination. Okay, now let's do solving by substitution as well. And then we'll stop this video. We'll call it part 1 of the review, and then I'll do a second video. I think it's better if we keep the videos a little bit smaller. Okay. All right. So substitution, similar way I do it. What I do is I label this as A and this is B. And when I have one of these equations written as y equals, this is set up beautifully for substitution. So what I say is I am going to sub A into B. And what that means is I am going to, wherever there's y in B, I'm going to write 5x minus 7. So what I do is I write 3x, because that's part of B, plus 2. And now instead of writing y, I am going to write bracket 5x minus 7. And I'm going to say equals 12. And this allows me now to have an equation with just an x in it, and I can solve for x. All right. So what I do is I solve it out. 3x, and then the 2 has to multiply in here. That's going to give me plus 10x, right? And this is going to give me minus 14 equals 12. Now I'm going to collect like terms and move things around. Remember, the x values stay on the left, the numbers go to the right. So I say plus 14 here, plus 14 here. That gives me 26, and this gives me 13x when I add these two together. Okay. Now I divide both sides by 13, and I get x equals 2. Look at that. Nice, clean answer. So I have half of my answer. I'm not all done. Now I'm running out of space down here, so I'm going to draw a line, and I'm going to do like this. I'm going to say sub x equals 2 into, and I can pick A or B. But almost always when I have one set up in the y equals format here, it's the easier one to use. So that's the one I'm going to do. I'm going to use it. So I'm going to say into A. I knew that was going to happen to me. I just knew that, right? I got to get my hand around and not touch the side of the screen. It's hard for me. Now, if you're wondering why I'm a little bit sloppy, it's because you're often trying to write without touching the screen. So now I'm going to write the A equation, and instead of putting x in, I'm going to put 2 in. So y equals 5 times 2 minus 7. That equals y equals 10 minus 7, so y equals 3. Now I have an x value and I have a y value. All I have to do is write my therefore statement, my POI. So I say, therefore, the POI, which stands for the point of intersection, is, and it's a coordinate, 2 and 3. And we are done the question. We have solved the equation or solved the linear system. Okay, I'm going to cancel or stop recording now. And this will be part 1. I'll pick up part 2 starting on quadratics next. We're on page 5. We're a little more than halfway through the pages of, all the questions that you're doing. And hopefully you're getting some value out of this. Feel free to rewatch and use it as much as you like. See you in part 2 shortly.